What's going on, guys? My name is Johnny Bandon and I'm your CCNA instructor for this CCNA video series. And in this video, we're actually going to dive deep into DHCP and go over our lab in EVE-NG. So to get started, of course, for our paid viewers, this lab is already going to come on our Google Drive that you can download and upload to your own EVE-NG instance with a lot of the pre-configuration done as far as VLAN assignment, IP addressing, baseline, right? Because in our labs, we like to just focus on the actual technology. We're doing DHCP, so all I really want you to configure is DHCP and not worry about everything else. For our non-paid viewers, if you're watching on YouTube, we do have a whole section on how to set up EVE-NG in a lab just like this. And then we also have our Git lab, which should be posted down in the description below, where you can actually go get the lab instructions. You actually have a network diagram, and of course a baseline right here that you can paste into your own sandbox environment and devices. So with that being said, let's go ahead and jump right in. So we always start off our labs by, I pull my GitLab over to the right, and then let's go over our instructions. So step one is going to be turn on all devices. So we're going to turn on all of our devices, which is already done, but if it wasn't, you'd come over here to more actions, start all nodes. And then step two, paste baseline from GitLab. I've already done that. If you haven't, of course, you can come grab it at the root of our repository. So at the root, you can come here, copy this, Control C, and then Control V. You can also download that repo to your local desktop, right? Okay, and now step three is going to be verify all VLANs, trunks, and IP addressing. So now we're just going to go through and just verify that the network is set up. So we're going to console in to all of our network devices. Of course, I use Secure CRT. And the reason I'm not just doing console into all of them, because we're only going to really work with one user here to make sure our DHCP is working. All right. So let me get this Secure CRT set up for you. Zoom in a little bit so we can clearly see what we're configuring. All right. So right now we're just verifying IP addressing and stuff on our network devices. So for R1, we're going to do show IP interface brief. We have our sub interfaces configured. And again, I have my network diagram over to the other monitor that you can't see. So that's how I kind of know what should be configured. I just don't memorize it, right? So again, got all those configured correctly. And then if we wanted to actually look to make sure our encapsulation is done correctly, we can do that as well with this show run interface command, looking at the actual sub interfaces and making sure that they're doing the VLAN tags correctly. Now let's go over to switch one. And switch one doesn't have any devices connected to it. So what we're going to do here is just show interface trunk. Make sure that all of our trunk ports are up. Awesome. And then switch two. We're going to do the same thing. Make sure our trunks are up. And then we're going to do show interface status. And this is going to show us that the VLANs are configured correctly or to the right ports, which they are. So the sales VLAN right here is supposed to be on Ethernet 0 or 1.1. And then we have our marketing VLAN should be on Ethernet 1.0. And then Ethernet 1.2 actually also has the voice VLAN configured as well. So if we look at that, we should have this configuration. And switch three, we're going to do the exact same thing. So show interface trunk, show interface status, and we're also good there. So it says native VLAN mismatch discovered on ETH01. ETH or 1.2, excuse me. Oh, yeah, right. So let me go over this lab with you guys real quick. So kind of get the lay of the land, right? So we have our environment here and we look at what we have. We have three sub networks, or three networks, I should say, for three different VLANs: our sales, our marketing, and our voice VLAN. So the voice VLAN is going to be for these devices right here. They look like VoIP phones, but it's kind of hard to emulate an actual Cisco IP phone in EVE-NG. So that's actually just a switch. And I changed what the image looks like. And that's just because I still want you to understand that now when you're building this voice VLAN DHCP pool, it's for a purpose, right? It's for our phones. So we need a what? We're going to need an option 150 address. And that's why I still put it in here, even though, I mean, you can't really test to see if it's going to pull from a call manager or not even a real phone, right? But in a lab environment, it's good to go through these motions because real world, you will be configuring DHCP pools that need that option 150 IP address. So that's why you see that native VLAN mismatch there, because this is essentially switch to switch, right? Okay. So if we wanted to fix that, I would just go on the other switch and put switch port access VLAN 10. But it's okay, it's not going to affect us. All right, so now on to our next step. So step 3 is verify all VLANs, trunks, and IP addressing. Step 4 is going to be configure all DHCP pools with the correct options needed for client devices to include a Google DNS servers and a lease time of 7 days. So we configure our DHCP pools at the device that has our default gateways for our networks. And it's going to be 3 DHCP pools that we need. One for sales, one for marketing, and one for the voice VLAN. So the command or the syntax is going to be the same each time. This name is just what you decide to name it. So the first thing we're going to do is define the network address in the subnet mask. So on our sales VLAN, it's /24. Okay, we need a space right there. And in this command, you're going to put the network address and then the CIDR. And I do believe that you could also just type out the actual subnet mask, and that works as well. I just do the CIDR notation, a little easier. And then we have to define the default gateway. So the command default router is going to say, hey, this is the default gateway for this network, which is going to be our sub interface on R1, which is 192.168.10.1. And that's it, just need the IP address. And then let's do a lease time. So this is going to be how many days that the device is going to lease an IP address. So our instructions say 7, so we do 7. And some enterprises I've worked at, they've just done 7. So now when I make videos, I'm just like, it's muscle memory, you know? And then we're going to set some DNS servers. So here we're going to do a primary and secondary DNS server, just like you would kind of see on your regular computers or your computer that you're working on at home. So I've opened up a command prompt here and type in ipconfig/all. You see here, I have the same thing going on my network. I have 2 DNS servers, one primary, one secondary. So if you want your DHCP pool to be set up to do that, we type in DNS server with the first IP address, and then we can put the second one. Awesome. And then for our sales, that's it. That's all we need to put. And then for our marketing, it's going to be literally the same thing. So I'm going to do this at a little bit faster pace. So network 192.168.20.0/24. Default router 192.168.20.1. Lease of 7. DNS servers. Then 8.8.4.4. Boom, done with our sales and marketing. And that's because they're just regular clients, right? If we wanted to set up Pixie, a pre-execution environment where we could image over the LAN, we could do option 66. We could set an IP address for that Windows deployment server, or option 67. And here, I think this is when you would actually point to like where the file is at, like in the actual Windows deployment server, the actual like directory. But we don't need to do that in our environment because we're not running that service. And now let's go ahead and make our voice pool. And this one's just going to have an extra. So what we're going to do here is the same exact steps. We need to set the network address. It needs a default gateway as well. Our phones need a default gateway. Lease time is going to be the same. DNS servers for those phones as well. And then here's the option 150 address. And here's how we do it. So you type in option, you do the option code, and as you can see, there's plenty, and then you have extended. I don't know what the extended option code it means, but there's your options, right? So option 150, IP address, and then we're just gonna make one up here. And now our phone systems, our Cisco IP phones, when they do a DHCP request, and they have this, or they're gonna request for an option 150 IP, the DHCP pool is going to give them this IP address, and then the phones will use that IP address to reach out to the call manager to do a TFTP connection of its configuration or its profile. Awesome. So that's going to be step 4. That's configuring DHCP on Cisco iOS. You just did it. Awesome, right? So now the next step is ensure that systems that need a static IP are excluded from the appropriate DHCP pool. So let's go over this. So let me get this out of view. So if we just look at this diagram here, I couldn't find a good image that I thought represented what a VTC machine looked like, so I just wrote it out. So this user endpoint connected right here on Ethernet 1.1 to switch 2, it's a VTC machine. Typically on a VTC machine, like if it's in a conference room or something, we want a static IP because we don't want that changing, right? Because whatever we're running, Cisco MCS, whatever collaboration server we're running, it's going to want the IP address of that system to be fully configured. So we would set this statically in the GUI of that VTC system, and this could also be a printer just as easily, right? And then we're not done. Once we set it static on the actual device, we need to go to our DHCP pool, whether that be running on Cisco iOS or a physical DHCP server running a DHCP service. We got to exclude that IP address from the pool so it doesn't assign that out, because you'll get a conflict essentially. And we just want, good architecture. So let's do that. So this is going to be part of the sales VLAN. So the sales team has a VTC system in their conference room, and we need to exclude the IP address from our pool. So we're going to do this from the pool first, and then we can go down to the system and statically set it, just to kind of go through the motions. So we're going to say that we're going to exclude .50. So now we go into this VTC system. Now we can set statically our IP address. And this is not a VTC system. This is the virtual PCs that you use in EVE-NG. All right, awesome. So now what we're going to do is, it says verify the leases on the DHCP server. We won't have any because none of our computers have done a DHCP request yet. So what I'm going to do here is just go into this sales VLAN. We're going to open it up. We're going to perform a capture right here on 1.1 to kind of see that DORA process or that DHCP process happen. And then we're also going to do it from the router's point of view. That's going to be on ETH00. And then let's go ahead and configure that the DHCP request on the computer here. And let's make sure it actually pulls an IP. So the command on these virtual PCs in EVE-NG is just IP DHCP. And it's pretty cool because it actually shows you like it going through the DORA process. Looks like it's going to fail here too. So now we got some troubleshooting to do. Okay, let's go ahead and see what we got going on here. It's always fun when this happens during the lab because now we get to do some real troubleshooting. So we're on PC 7 there. Let's go through this. So we should be access VLAN 10 right here. Then we should have a trunk here. And then we should have our sub interface configured here for VLAN 10 tagging. So let's go through that and let's make sure we have that set up correctly. So we're going to be on switch 3. So let's go to switch 3. And I'm just going to go ahead and shut that interface 1.2 down just because I don't want, that's an annoying command. Or I don't want that syslog message to keep coming across. So PC 7's on Ethernet 1.1. So let's go look at 1.1's configuration. All right, we're in the right VLAN. Make sure we have the VLAN created. We do. Okay. And then we type in do show interface trunk. So ETH02 to switch 1 should be good. Switch 1, let's make sure we have that VLAN created. Ooh, that could be our problem there. Let's go ahead and make these VLANs real quick. And then do show interface trunk. All the trunks are created properly. R1, let's make sure that the actual physical interface is up. Yes, it is. That's a common mistake. And let's go ahead and try this again. Still no good. I wonder what the issue is. Let's come here and let's see if this guy can. This is supposed to be a different IP address. PC9 is sales VLAN, so that's supposed to be .10.50. So that was a mistake. I did it in the voice VLAN for some reason. That's not our issue, but just want to see if statically I can reach this default gateway. So ping 192.168.10.1. She was full. What is going on with our network here? Because it seemed like we had a good ping, and then it started saying Q was ICMP timeout. Go to switch 2 and just go ahead and shut interface 1.2 down as well. And send that ping again. Okay, let's go ahead and statically set this guy here. 10.1/24 192. Oops. Give this .10/24, and then the default gateway is .10.1. Let's go ahead and run that ping again. 192.168.10.1. I keep getting the timeout commands. Let's check this out. I mean, what could be the issue? Yeah, no IP address there. .10. That's configured correctly. I don't think we have any spanning tree nonsense going on. So spanning tree VLAN 10. I mean, this isn't the root bridge. That shouldn't be an issue though, but let's just go ahead and make it the root bridge. Okay. That's shut down. We don't have those mismatches anymore. Let's try this ping one more time before I pause this video and come back and keep going on with DHCP. All right, so I'm gonna pause the video, do some troubleshooting, and then I'll go over with you guys what the fix action was. All right, welcome back. I just did a quick pause, and literally while I went away, I just tried the ping again and it started working. The only thing I could think of is because I had those native VLAN mismatches here, that maybe it was trying to send traffic out to one of these and they were the root bridge and it wasn't trunked. And I would probably, my best bet would be that's probably what was happening, is that this switch here, or this switch here, was the root bridge of our network and they weren't trunking. Because I guess, yeah, they weren't trunking, so there was no inter VLAN traffic. So once I made switch 1 the root bridge and it reconverged, it looks like now our pings are working. So I'll probably go ahead and test that after just to see if that's happening, if it happens again. Because let's say we know this out. Yeah, there's kind of errors here. Let's kind of try that ping again. Looks like we're not gonna work. So I'd be willing to bet that that was our issue, is that these became the root bridge, these switches here. And that's a mistake on me. I should have realized that. But now that do show spanning tree VLAN 10, the root is 0.1. Then come up to switch 1 and its root's 0.2. Come down here to switch 3. I'm just following the root path, right? Do show spanning tree VLAN 10. Again, these videos are always fun when we got some. Yeah, it looks like it was in a loop for some reason. Now it's going to 0.0. That's the root bridge, which is back to switch 2, which says the root is up towards switch 1. So yeah, it looks like we had a broadcast storm. It's crazy because, well, anyways, let's just go ahead and move on, right? So let's go make switch 1 the root again. And then now we have connectivity. Because the point here is that we're trying to look at DHCP. So I still have those packet captures going on. Let's go ahead and take those off. Yeah, let's start new captures on a new computer that hasn't been statically set and messed with yet. Yeah, go ahead and stop these captures. Okay, so now we'll come into PC6. We'll start our capture here on 1.0. And let's see this DHCP process. So PC6 is going to be IP DHCP. And let's see if we can finally complete our door process. All right, so you can see here on these virtual PCs and even G, it's pretty cool because it actually shows you like the door process right there. Like, okay, we did our discover, another discover, now offer, request, acknowledgement. I'm gonna go ahead and pause this capture. We're gonna come back to it. And now let's go back to R1, do some verification. So we do show IP DHCP binding. We can see PC6's IP address here with its MAC address, pretty cool. And then its lease expiration, which is 7 days from March 10th. We can do show IP DHCP pool. We can see that this marketing pool has one leased address, and then we have all of its information there. And we can actually just look at it directly by referencing its name. We can also look at show IP DHCP. We can look at the database even. There's so much we can do here. There's nothing. I think that actually is for a DHCP snooping command. Let's see, server, statistics, and look, there's so much you can do, right? Looks like this is probably just counting how many requests or DHCP messages they're getting. But really the big two is show IP DHCP binding to see what is currently allocated. And then show IP DHCP pool, and we'll reference the actual name of that pool again. Another important command. And then one that if you're seeing conflicts, you can actually do show IP DHCP conflicts. We don't have any. And if we need to clear it, we could do this command, clear IP DHCP conflict, and you can choose the specific address, or you can do this clear all with that wildcard. Awesome. So now let's go ahead and look at that packet capture. So expand this out. I'm going to zoom out a little bit so we can go back up to where we started that DHCP process. All right, awesome. So this was the first DHCP discover message that we saw. So let's open this up. So you can see here the Ethernet source and the destination is a broadcast. So the Ethernet header is going to be a broadcast with the source at its MAC address, right? That computer's MAC address. And then we have the IPv4 address. The source is going to actually be old zeros, meaning when the default gateway or the DHCP server sees that, they're going to be like, okay, there is a request out there, but I don't know who it's for. And this is going to work in our scenario on a VLAN on a subnet basis, because if we did a packet capture on this link, you would see that 802.1q encapsulation as well. So only that subinterface 00.20 would be looking for this. And then we can see the source port 68, destination port 67. And then the actual DHCP packet here is pretty much empty. We're pretty much saying like, hey, we don't know anything. And then we need a unicast back, is essentially what that's saying. And then we have these options here, like option 53 is the type discover message. Option 12 gives a host name. So you see the actual option field in that DHCP packet. Then you see the option 61 is the client identifier. So essentially we're saying like, hey, this is our MAC address. So when the DHCP server sees that, it has its MAC address, it's going to use ARP actually to be like, I know where this came from, and now I know the destination of where to send my next packet. So if we look at the next message here is actually ARP. You see that? So this is the DHCP server saying, hey, like, we need to find this, okay? And then we see another discover message being sent. So let's go ahead and open that up. And let's look at what we got. It's still empty. We still have the same options configured. And now the second is going to be a DHCP offer message. We can kind of see that here, offer. So let's open that up. I wish it just didn't have this when it came out. I'm sure there's a setting you can change. Okay, now let's break this packet down. So now we have the source and destination is 192.168.20.2. We see the source port change. It flipped. Now it's 67 and destination 68 because it's coming from the server. And this is unicast, right? No longer broadcast. So now we see in this a lot more options. So the renewal time value, the rebinding time value, which is that lease, right? The subnet mask, the actual default router, and then DNS. So pretty cool, right? We actually see those options configuring the extra, right? Not just an IP address. So it's telling it your client IP address is 192.168.20.2. And even though it doesn't know it yet, like the computer doesn't know it's 20.2, but it's okay because in this destination field on the Ethernet, it's good to go. So now if we look at the request back, still all broadcast. We still have the same source, but now we know the destination in the Ethernet field. So now we can still do that kind of more direct communication instead of it being fully broadcast out. So pretty cool to see, right? That the DHCP request packet, yes, it's broadcast in the IP header, but it's unicast in the Ethernet, in the layer 2 header, the Ethernet header. And now it's saying, hey, we need to request these options, right? And then if this was a phone, it would put in, we need option 150. Then the final step, that acknowledgement, a unicast message. Get this out of the way. It's just making sure that it has everything, acknowledging that this is everything, all the options that it needs. Pretty cool, right? Kind of break down the actual DHCP request in there. And then we have ARPs after that because now this computer needs to like, okay, I have IP addressing. Now I'm set up. Let me send out an ARP message real quick to my LAN. Awesome. So that's going to be it for this DHCP lab. Sorry about that little fumble earlier. If you're just trying to learn DHCP, it can be annoying when you get that extra troubleshooting. But for those really excited about learning, there you go, right? That's definitely something that can happen in real world where maybe a junior network administrator puts a switch on the network that kind of messes things up, right? So I want to thank you all for viewing and stay tuned for our next lab where we go over DHCP relay.